to construct unit graph for S from S curve. In this case, to construct unit graph with the rainfall duration are not 2, 3, or 4 times of the rainfall duration, so we have to use the S curve. Well, what is the S curve? How to construct S curve? S curve we can from the series of the unit graph. You have to this one. We have to use this series of the unit graph, make a time lapse between each unit graph with the TR. Okay, TR is mean duration of rainfall, and put together in infinity and add up it together to get the S. You can get the S. You can get the like the S curve. So so for unit graph, this is in the put together, add up in the infinity term. Okay, we add. This means if you okay. So at the end of the tail of the first unit graph, we expect that we get the maximum or the peaks of the should be constant for the S curve. So that is how to construct S curve, and we can the method is we add up the series of the unit graph with TR rainfall duration from TR rainfall duration, and put the each unit graph with the time lapse TR in a series and add together. And another picture show like this. Okay, so it means we TR is mean the duration of rainfall. Okay. So we put all rainfall together in terms of continuous rainfall together, and finally we get the S curve from the summation of the unit graph. Okay, this is unit graph put together and in infinity number. Okay. And the next step, if you want to find a new unit graph for the new duration, for example, in this case we say that TR is, let's say 6 hours. Okay, and we want to find the new duration is 2 hours. Okay, so it means the next step we make the overlaps between two S curve with 2 hours to TR prime. Okay, that is this is the first and second S curve with the time lapse of the TR prime. Okay, and we subtract the two S curve and we get this the new unit graph. But the volume is a ratio between TR prime and TR. And the next we have to adjust the area under the curve to be 1 again. So it's divided by this one is the ratio is mean 2 divided by 6, and it said that to adjust the area under the curve to be 1 again, so we have to divide ordinate. Divide ordinate of the graph in C by this number. So we have to if we have coordinate of Q, we have to divide it by 2 over by 6. So it means we have to multiply by 3 to the coordinate of Q to get the area under the curve is equal to 1 again. Okay, and look at the example how to do numerically. Okay. And the example is to construct the construct unilateral graph with 2 hour duration from unilateral graph 6 hour. We see from the previous example. Okay. So the next we can find the number of unilateral graph for the overlap. Okay. Don't need to put in terms of an infinity number, but you kind of what is the minimum number from based on this equation. Nu is nu number of the overlap of the unit graph for overlapping is equal to t. T is base time for unit graph divided by expected rainfall duration. So, okay. So in this case, if we back to this, what is the base time? You can see that base time is just 34 hours. Okay, 34 hours. So we can find that the Nu is equal to 34 hours divided by 6. Okay, the x6 is duration of rainfall. So it's about 5.67. So we use 6 sets of the unilateral graph. Okay, we have 6 sets. Okay, so we put the 6 sets of unilateral graph in the table. As you can see that this is for the first set. And overlap is 6 hours. Okay, 6, 12, 13, 14, 30. Okay, and each one is overlap is 6 hours. 4, 5, 6. Okay, 6 sets of the unilateral graph. And the next we put together is summation on the column 9. Okay, this is summation of Q. So we got S curve, but you can see that the number is maximum is 50, and later on is smaller. So because in this case we assume that it's just only a 6 set, but actually there is infinity term of the unilateral graph. So we can adjust the S curve to the correct S curve. Next step, we can find the maximum. What is the maximum Q peak for the S curve? So based on this equation, Q peak is equal to 2.78 time area divided by TR. And how to get what is 2.78 come from this number. And we can estimate the Q peak. Okay, Q peak from 2.78 time area 104 and divided by 6. So we got about 48.2 meter per second. So you can use this for the Q peak. Next we adjust the S curve like this. If you look at it's like this zigzag curve. Okay, we can adjust to smooth curve like this. Make it smooth, but adjust in column 10. This is for okay, we adjust on column 10 and bring the maximum into the 11 from the maximum should be 14.20. So that's maximum. Very smooth curve, and keep the maximum is 48.2. Okay, and the next we bring another set of the S curve between 10 and 10 and 11 is a 2 S curve to adjust S curve and make the time lag just 2 hours. Okay, this is 2. Okay, just 2 hours for first and second S curve. And the next we find the difference between column 10 and column 11 to get column 12, the difference between two S-curve. And the next we adjust the column 12 to get a smooth curve. Okay, so we got column 13. Okay, and we can check do again for the last column is to find the final unilateral graph. This is for the unilateral graph for 2 hours, unilateral graph for 2 hour rainfall duration. Okay, you can check that if you check this unit, it should be is equal to 1. Time step is 2, 60, area convert to centimeter is equal to okay. So it's after adjustment we get the unilateral graph. The area under the curve is 1 centimeter. Okay, so now we can this table showed how to develop S-curve from 6 hour rainfall to get the new unilateral graph for 2 hour rainfall. Okay.